Assalamualaikum and hi everyone. My name is Husna. So today I will explain about background of study. The population growth is described as the number of organisms of the same species living in the same area at the same time and capable of interbreeding. According to the Department of Statistics Malaysia, the population of Malaysia in 2020 is estimated at 32.7 million as compared to 32.5 million in 2019, with an annual growth rate of 0.4%. Currently, Malaysia is experiencing population growth at a rate that is gradually slowing down. Therefore, estimation of population in Malaysia is vital for development, employment, and business planning. With the knowledge of future population, it is easier for the government to plan about the need of basic services such as education, health, adequate infrastructure, and amenities like housing and water supply to create sufficient jobs to meet the demand of increasing population. However, in this last one, we are focusing more on the population of male in Malaysia. Population of male in Malaysia is growing fast and its boundaries are extending day by day.
Moving on to the purpose statement part, male population in Malaysia is estimated to be higher from 2000 until 2019, but it turned out that the actual male population in Malaysia is lower than the estimated. We will see the estimated of an actual male population data later that will be presented by my group mate. So the actual male population in Malaysia is lower than the estimated due to there are higher death rates in men compared to women in Malaysia. Hence, we need to identify and come up with a solution to know how much of male population is needed to reach the estimated value. For scope and limitation, we limit our solution by using male population data in Malaysia from 2000 until 2019, indicating 19 years. We also use Montage model to find out the solution as depicted in the slide dp over dt equal to kp. The p actually indicating the population, dt indicating the time which is the year, and the last one is the k indicating the constant.
Next, the objective of this task 1 is to observe the population growth in Malaysia and how it relates to the Montage model. Secondly, to predict the future and past value of population growth in Malaysia. Thirdly, to model the male population in Malaysia using a first-order differential equation based on Montage's growth model.
Now we're moving on to implementation. In our research, we retrieved the data of male population in Malaysia from 2000 until 2019 from the World Bank report. The timetable that we use is 19 years. The reason we choose 19 years because we need to limit the solutions. Since the rate growth is proportional to the number of male populations, the general solution of Montage model can be concluded as Pt equals to 8 exponential to the power of k times t. This is the tabulation of data of male population in Malaysia from 2000 until 2019. For the computation process, firstly, we will use separable first-order differential equation to separate the variable p and variable k. And then we will integrate both sides until we obtain p is equals to exponential to the power of kt plus c. And then we will simplify the general solution of p is equals to ae to the power of kt plus c, where e to the power of c is equals to a. Using energy condition of t is equals to 0, which represent year 2000, where the p is represent population is equals to 11818,008. And then we'll substitute the value and then we will obtain the value of A is equals to 11818,008. Hence, the general solution will become P is equals to 11818,008 exponential to the power of K times T. And then we will find the value of K by using the condition of T is equals to 1, which represents year 2001. And then the P is equals to 12,090,532, and then we will substitute the value into the general solutions, and then we will obtain the value of k is approximate to 0.0228. And lastly, the particular solutions now has become pt equals to 11818,008 times exponential to the power of 0.0228 times t.
Next, analysis and discussion. So, to see the accuracy of the values, we can compare the actual values and the values obtained by the particular solution. So, focusing on years 2016, which t is equal to 6. So, the actual value is equal to 13,450,753, while the estimated value is 13,550,513. So we can see that there are slightly difference between both value. So we can calculate the differences by subtracting the estimated value with the actual value. So the values we obtain is 99,760. So by this value, we can conclude that the obtained value is not accurate because there are slightly differences between both of the value from the calculation we made before. So next is the percentage error. To calculate the percentage error, we can use the formula, which is percentage error is equal to standard value minus with theoretical values divided by standard values and times by 100. So the percentage error we obtain is 0.74%. Overall, it is proven that the obtained values by the particular solution is not 100% accurate, but since the percentage error is only 0.74%, which is less than 1%, we can say that the particular solution is acceptable to be used to predict the values of the male population in Malaysia.
Continue for this discussion. So the estimated value is not tally with the actual values because we use the symbol approximate. This is due to the constant value k is in decimal places. Next, we have discussed that financial problem and high mortality rates have affected population in the past. However, high fertility rates and low mortality rates have affected population growth in the future. As we all know, raising a child requires a significant sum of money to provide them with a decent education, food and shelter. Additionally, outbreaks of infectious disease, famine and war can lead to high mortality rates. The country can use this assumption to predict future populations. By knowing this, future economy can be well managed as the country are already prepared of the consequences that might happen.
Next, my name is Arif and I'm going to talk about the conclusion. So we proceed to the conclusion. So for conclusion, we receive many experience and benefit as a sequence of the assignment. So firstly for task 1, we obtain a great deal of knowledge about male population in Malaysia from 2000 to 2019 and the evolvement of male population in Malaysia. Then we learn the ways to predict future and the past value of population growth of male in Malaysia by using the particular solution. So next for task 2, we have developed the skill of self-learning integration. We discover the ways to use the numerical integration such as the Simpson's rules to solve functions that are difficult to integrate analytically. So for recommendation for task 1, we consider that the accurate data is required for task 1 in order to achieve the accurate calculated values. As a result, we can predict the potential male population without a minor inconsistency. So for task 2, to allow a larger difference, we consider to use larger difference between two sub-intervals. Okay, that's all from us. Thank you everyone for contribute in this assignment, and also Dr. Syazwan for giving a guidance to us.